Hello, my name is Tanmay Kumar Dikshit, and for Cloud Platform Programming Project, I have chosen Finance and Economics domain. In this, I have created a banking application using Python and Django, which serves the clear purpose of providing users with a simple and secure way to manage their finances. The motivation behind its development stems from the understanding that people require convenient access to banking services through their devices, be it a smartphone or a computer. Our app allows users to perform essential financial tasks, including depositing and withdrawing money, checking their account balance, uploading profile pictures, and subscribing to a bank-related promotional messages and notification related to the app's updates regarding the application. To achieve this goal, we have used AWS services, which is a technological foundation ensures that our application runs reliably, securely, and with scalability. With AWS, we can offer a user-friendly banking application, enabling individuals to manage their finances effortlessly. Now let us see a quick demo of what our app does, and later we will understand how the features and the functionalities actually work. This is the registration page of our web application where new users need to provide their details to create an account. This includes name, email address, and a strong password. Upon successful registration, users will be redirected to the bank's dashboard. Pre-existing users can simply click on the sign in here option, fill out the details, and can move into their account. So now let's create an account and move on to the next part. As you can see, we have been redirected to our bank's dashboard, where we can see registration is successful. A welcome message getting displayed. We can see the account balance in the transaction section. If you enter any amount over here, we can select what transaction type you want to do with it. In transaction history, all our transaction will be stored over here. And if you want to log out from our application, we can do it from this logout option, and it will take us to the login page. And if you want to subscribe to any promotional messages, if you want to receive any promotional messages from my bank side, we can simply click on the subscribe option and then enter our email ID. Then we will be getting all that promotional messages from the bank side or any update related to our application. And if you want to upload a profile picture, we can do it right from here from the upload photo part. And if you want to delete our account, we can also do that with this delete account function. So let's first try to make do some transaction over here. If I enter €1,000 and select deposit as a transaction type, we can see that our account balance has been updated, which is €1,000, and transaction history has been recorded. Now, if you like do withdrawal, we can see that our account balance has been updated again, and another transaction has been recorded in the history. Now let's try upload our profile picture. When we click on this upload photo part, we get this web page where we have to choose a file from our system. I'll be selecting this one, and when we click on upload, this file will be getting stored on AWS S3, where we have created a bucket. This is our bucket user photo, and when we refresh the page, we can see that our photo has been uploaded in this bucket. Here our photo has been uploaded, and when we go back to our dashboard, we can see our profile has been uploaded over here. Now let's see, let's explore the subscription option over here. When we click onto it and enter our email ID, we'll be getting a subscription mail from AWS SNS service. See, we have got a subscription mail from AWS, and when we confirm the subscription, it says a subscription has been confirmed. Now when we use the AWS and refresh this page, we can see that our email address has been stored under this subscription option over here, and which says confirmed. This is the SNS topic that we have created, and all the users will be actually over here. Getting back to the dashboard, this over here, our transaction part has been implemented using a custom Python library, which we have created for this transaction function over here. Now let us see how all these functionalities are actually working and how we have used AWS services in our banking application. Before we understand how AWS services has been implemented, let us see how the admin panel would work and what things can be done from there, and how the promotional messages will be sent to all the subscribed users. So when we enter the credentials of admin part, we can see in authentication and authorization groups and users has been mentioned in bank accounts and transaction. So what we can see in users, all the list of all the usernames are there, like the one we created before. In the transaction part, we can see the transaction which were done from from that account that we have created. We can edit these transactions from here, like if we click and delete it from here, and this one also. And if we add a transaction from here, like, to the account, let's say 5,000, and it would be a deposit. And if we log out and go back to that account, we can see the balance has been updated and the transaction history has changed and has recorded new transaction. Now let's see the promotional part, how the promotional messages will be sent. So if we write a new dialog box, a new page will appear, the promotion page. Here, let's see, we can write the bank is offering 14%. Just click on home loan and we click on send promotion. You can see that our that we receive a promotion message on our email address that see the bank is offering 14% interest rate on home loan. Now this whole process has been done using Lambda, SQS, and SNS, where the message is being sent to the SQS queue, and the SQS queue is actually triggering Lambda, which and the Lambda sends the message to the SNS, and SNS sends the message to all his subscribed users. We will understand this part later on in the video, where we explain the services individually. From there we'll understand how this process has been implemented. So now let's move on to the part where we understand how AWS services has been implemented in our banking application. For handling the transaction part, we have created a Python library called transaction processing, which defines handling financial transactions such as deposits and withdrawals in an object-oriented manner. The key components of this library are transaction class. This is a base class for transactions. It initializes with an account and an amount. It defines an abstract process method, which is meant to be overridden by subclasses. Deposit and withdrawal classes are the subclasses of the transaction class. Both override the process method, where deposit class increases the account balance, saves the update, and withdrawal class decreases the account balance, saves the changes. Transaction validator class contains a static method validate to check if the transaction amount is valid, which is greater than 0 or not. Then the transaction manager class has a method execute transaction that takes a transaction object, validates it using transaction validator, and if valid, processes it using the process method. We have applied this library in our dashboard function where deposits. We have applied this library in our dashboard function. The deposit and withdrawal classes are used to create transaction object based on the type of transaction. This part utilizes the transaction manager to validate and execute the transaction using its execute transaction method. The process method of either deposit or withdrawal is called when manager execute transaction executes. This method, as defined in our library, updates the account balance and saves the changes. So when we deposited 1,000 euros, it was done through transaction form. The form is validated by Django. Then the deposit object is created and processed using transaction manager, which validates the transaction and updates our account balance by adding 1,000 euros. And the transaction was recorded in database, and we received feedback with a success message seeing our updated balance on the dashboard. Now let us understand how AWS services has been implemented in our web banking applications. So starting with the first one, it is AWS Simple Storage Service. In this, we have initialized S3 client with Boto3. This client is used for uploading photos to S3 bucket. Then in this part of the code, we have a user profile picture function, which handles the upload of user profile picture when a post request is made. It processes the submitted profile form, which includes the user's profile picture. Upon validation of the form, the profile picture is extracted from the request file. The function then attempts to upload the file to an AWS S3 bucket using S3 upload file object method with the bucket name and the file name from the form data. If the upload is successful, it constructs the image URL based on the S3 domain and file name and saves this URL in the user profile picture model associated with the current user. If an error occurs during the upload process, it catches the exception and displays an error message. Now this part of the code provides feedback to the user about the success or failure of the upload operation using Django's messaging framework, and the function concludes by rendering the bank upload HTML template, passing the form for user interaction. The second service which we have used is the AWS Simple Notification Service. So on the dashboard, there's an option called subscribe, and user clicks on the subscribe option and enters the email ID. Then the admin would be able to send the promotional messages, and the user will be getting those messages on the email ID. Now what is happening here is that the user is actually subscribing to the SNS topic that we have created on AWS. So, and in that code, we have implemented it using a subscribe function. Which will be handling the email subscription request. The function checks if the request is a post request indicating a form submission. If it's a post request, it processes the submitted data using subscribe form. Upon validating the form, the user's email address is extracted from form clean data. Then using SNS client subscribe method, using client subscribe method, the function attempts to subscribe the extracted email to a specified AWS SNS topic. In our case, that is the email notification. The try except block captures any exception during the subscription process, displaying an error message to the user in case of any failure. And that failure could be due to a network issue or something. The third service which we have used is AWS Simple Queue Service. For which we first created a queue in AWS and noted down the necessary credentials, and then created this send promotion function, which is secured by a decorator at the login required, ensuring only authenticated user can access it. It processes a post request where an admin submits a promotion message through a form. The message is retrieved from the post data. Upon receiving a valid promotion message, the function constructs a message object and send it to an AWS queue using the SQS client send message method. The function provides a user feedback via Django messaging stating that the subscription the message has been sent successfully, and the function enters the bank promotional HTML template for displaying the form or feedback. The first service which we have used is AWS Lambda. AWS Lambda is used for running code in response to events without needing to manage servers. We use this to process the messages received from an AWS SQS queue and broadcast them to AWS SNS. Lambda handler is the main function that AWS Lambda calls when the Lambda function is executed. It takes two arguments, event and context, which provides runtime information. The script initializes an SNS client using Boto3. This client is used to interact with AWS SNS for sending messages. The function iterates over event, which contains the message received from an SQS queue. AWS Lambda automatically fetches the message when the function is triggered by an SQS event. Each extracted SQS message is sent as a broadcast through SNS. The SNS client publish method is used for this purpose. It specifies the topic ARN of the SNS, the message itself, and the subject for the notification. And after processing the message, the function returns a response indicating successful processing. So when admin writes a message over here, it sends to the when the admin writes a message here, it gets stored in the SQS queue. The Lambda function then gets triggered and extracts that message from the queue and pushes it to AWS SNS, and then AWS SNS sends it to the user to all that user who have subscribed to the SNS topic. Fifth service which we have used is AWS EC2, utilizing a T2 micro instance to host and deploy our application. The significance of EC2 lies in its capability to create a public-facing environment, allowing seamless accessibility for users over the internet. And for the last AWS service, I have used AWS Relational Database Service for storing user information and transaction history of our banking application. For doing so, we firstly created a database. On AWS RDS and opted for PostgreSQL. Then created a database and noted down all the credentials and integrated them into the application setting.py file. Now, to facilitate the connection between our application and the database, we turn to pgAdmin, which is an essential tool outlined in the AWS documentation for accessing a database built on the Postgres engine. So on the pgAdmin, if we write here /user and click on this run option, it then displays the name of the user, their email ID, and all the information about it. As we can see, is email ID, name of the username, and also it has stored the password in encrypted format. It also shows the when was the login done. And for the transaction part, we can write over here bank transaction. Then we can see that the 5,000 which we deposited into the account to the admin panel has been uploaded over here. We can see the timestamp, the amount number, type also it says deposit. So this is how the pgAdmin works, and it stores, and this is how the AWS RDS has been used for storing all the information of our banking application.